Okay, hello, I'm glad to see you there. This is my second PromCon. I was first PromCon was in Munich last year. And I'm here to tell you how we observe not only world's most famous 3D print farm, but also how we use Prometheus at Prusa Research. Yeah. Who am I? My name is Pavel Strobl, and I am DevOps engineer at Prusa Research. Next, I am also a Cloud Native Prague organizer. We are organizing meetups about Cloud Native technologies. My main topic is SRE and observability. I sometimes do something about infrastructure here and there, but that's not main thing I would like to do. So I'm more like SRE and observability guy. Besides that, I also like to homebrew my beer. And did you know that you can actually observe a process of fermentation of beer with Prometheus and Grafana? And I play a lot with hardware and IoT. 3D printers are my thing. I like messing with my cars and something like that. So, how do we use Prometheus? If you think about Prusa Research, you'll think, okay, these guys made 3D printers. But it's not only that, because we run multiple web services, for example, printables or eShop. And we need to monitor somehow these services. That's why we use Prometheus. This is our stack. It's not complete, of course. We use GCP, Google Cloud Platform, and we use Google Kubernetes engine. So it's much easier for us to manage our Kubernetes instance. And we have 2 clusters. These are pretty small clusters, but still there are 2 of these. We don't need development cluster because devs develop at their own machines. Okay, let's move to staging. At staging, you will see printables and eShop as examples of applications. And then there is running Prometheus and Loki. Loki is for logs, but let's talk about Prometheus. We use Thanos sidecars because at our production cluster there is running Thanos that can actually offload our metrics to object storage that is called Google Bucket. And even in production cluster, we have Prometheus with Thanos sidecar, but you can actually access Prometheus and production directly. We don't have ingress for Prometheus at stage because it doesn't make sense. We use that Thanos sidecar. Okay, this is how alerting looks like, because I think alerting is pretty difficult to set up. And we use 2 approaches, because we use 2 approaches in deployment. We use 2 approaches of alerting. Let's say we have Terraform, now OpenTofu, if you heard about that, and we use Argo CD with crossplane. You probably heard about that. You can actually use Terraform just for spin up of cluster. We use that for internal tools, and then we use Argo CD for our applications. So that's the reason why we use Prometheus Alert Manager for alerting about our cluster and tooling. And then we use Grafana alerting for alerting of applications. So our developers can easily ClickOps way create their own alerts, and they see everything they created. But actually, I am the one who creates these alerts, and just the developers can see how this works. We use our pipeline is that we use Slack, and then escalation is our on-call solution. Why did we choose Prometheus? Okay, because for us as DevOps department, it's open source. I'm not talking about WoW of our company, because I'm in DevOps department. For our web applications, I'm not in development. And one of the reasons is open source. And it's part of CNCF. We are heavily CNCF based. We have most of our tools are from CNCF, so it's a logical choice of using of Prometheus. Next is widely used. If you have issue with Prometheus, probably someone already solved it. Then exporters for everything. There's a lot of exporters. We use them also. For example, node exporter. Everyone should know that. PHP FPM exporter. Then even Minecraft or Counter-Strike exporter. If you want to, you can export every single metric you want to Prometheus and use it however you like. And it's very easy to implement your own exporter too, because we actually created body Prometheus exporter. I will talk later. But you can, let's say, have Python application, and you can create your own Prometheus exporter inside your application. And it just works. Pretty easy to config at first. It gets difficult later. But what about the printers? Yeah, I'm here about the printers, not only about our infrastructure. What if I told you that you can observe our printers with Prometheus? And here we go, body Prometheus exporter. This is actually body. This is Joseph Joseph dog, and our boards are called body, X body, XL body, body for Prusa Mini. But we don't expose metrics from the printers itself. So there is I needed to find another way, and it's kind of cheat way because Prusa boards expose Prusa API, Prusa API, and I use these endpoints that expose metrics about telemetry about how it's printing, status of job, printer version and such, and transpose them to Prometheus metrics. Of course, I use Prometheus as backend for metrics and Grafana dashboard for multiple printers. Right now, there is implementation for body-based boards. It's MK4, XL, and Mini. And NC support is experimental because the exporter is in alpha. It works before, it doesn't work right now. Sometimes it works on my machine. And let's go here. Yeah, this is our body boards. As I said, every single of them expose Prusa API. How to get data to Prometheus? You need something like Raspberry Pi. I used Raspberry Pi 4 and even 3. It's enough. If you are running Prometheus at this device, you will probably destroy the micro SD card that you use. So I chose Grafana Cloud. Let's ask, but why? Yeah, it's hardware. So it doesn't need to be observable, right? Yes and no, because if you don't know it's something wrong, then you will be happier than if you know it's something wrong, right? I wanted to get data from printer to Prometheus or something like that. It doesn't need to be a Prometheus. And I want to create my own dashboards. Grafana is actually pretty great for this. Custom alerts. I can imagine that, let's say, on university, you are printing your own model on printer. Somebody came along, want to print their own, and said, scrap it, 60%, and it failed. Yes, of course, it failed. And in Grafana, you will see that print was already actually stopped, and it's not that it was it failed. And of course, the answer, but why, is why not. I wanted to prove it's possible. It was at first a proof of concept, and wanted to get better in Golang and better understand Prometheus ecosystem. How does it work? It's standard Prometheus exporter with standard libraries, nothing fancy, Golang 120, and it triggers Prusa endpoints. Every single scrape. That's kind of issue because if you think about it, every printer have 4 endpoints, and if you have one printer, then 4 endpoints is pretty great, nice. You have 10 printers, it's 40. You have 100 printers, it's 400, and so on, so on. You still need Raspberry Pi or something like that. Not necessarily Raspberry Pi. You can use x86 server if you want to. And you need to run Grafana parsers, as we heard today, or whatever. It's in Prometheus. You can visualize it anyhow you want. I have all over dashboards for Grafana right now, only. But what about more metrics? We actually not expose, but it sent our metrics. It's the official way in quotes in syslog format with UDP to our internal server, like inside of our company, and you can actually send them to your syslog collector too. Or you can use InfluxDB by default. You can find source code in our body firmware repository. And that's why I created body observability collector. Body observability collector is in experimental stage early. Sometimes it works on my machine. And PromTail as a processor of logs, because I can regex every single metric I need. There is implemented only a few of these, and expose them as such metrics for Prometheus. As I said, more like proof of concept. It works. And I use also body Prometheus exporter as additional source of data, because there's some kind of some data in Prusa Link API, and then some data in syslog exporter. But what about that farm? Yeah, that's something that is, let's say, issue, and it's complicated. Right now, solution would be syslog UDP plus InfluxDB, at least 50 kilobytes per second per printer. It's much higher while printing, like 10 times more. And about 600 printers, 600 by 1500 kilobytes per second, that's a lot of traffic. It will easily destroy our network. And data needs to be parsed. They are not in standardized format, so we have actually right now script in Python, and that doesn't run pretty well. And now, status of our farm is we have a lot of MK3 printers. We have metrics from these printers, actually, and it's terabytes of data, terabytes, because we are printing for a long, long time. And these are just data. We have no proper visualization. So as I always said, that if you have too much observability, it's almost useless as no observability. Because if you have data, but you cannot visualize them, it doesn't make sense to generate these data. Eventually, we will, of course, upgrade to MK4, and that gives us opportunity to do it differently. And of course, there are a few excels at farm, and these are same as MK4 as terms of endpoints. Future is the meme on the right. It's not true anymore because we actually released 5.0 firmware for Prusa Mini with input shaper. But who knows what is the future? Maybe OpenTelemetry. Actually, at DevOps, we already use OpenTelemetry, and I'm really too happy to hear that Prometheus support will hopefully support OpenTelemetry. Actually, I know it because there was a blog post. And we use Prometheus in backend, so it will be awesome. But why we use OpenTelemetry is because tracing. That's the main reason. It will be soon a trademark. So hopefully, some kind of solution will be done soon. Or can it be my Prometheus exporter for body, or it will be in firmware? Who knows right now? Syslog is in firmware now. You can actually use it, start Docker Compose up in our repository, or you can use body observability collector. It's open source. You can contribute. I will be more than happy. And last but not least, body Prometheus exporter is in alpha stage right now, but it's available. You can use it. Probably I wouldn't change metrics, but still it's alpha stage. So it can work now, but not tomorrow. OK, how does it look? This is one of the dashboards that I created. It's pretty harsh, rough on the edges, as always, when you're creating dashboards the first time. It's a dashboard from February, March, maybe. I didn't updated it, and it looks like that. As you can see, there's a lot of information. There's target nozzle temperature, target bed temperature, everything you need to know while observing the printer. And of course, there's one issue with scraping these 4 endpoints. And if you're have your scraping interval like 10 seconds, then sometimes printer doesn't have enough processing power to answer. So you'll have no data for that at that time. Or it can look like this. Let's say you have farm, you want to have a lot of printers, and you want to visualize every single one of them. What is printing, if it's in failed state or something like that, and what types of printers you have. See, there's one MK4, 2 minis, and one MK3. And of course, Einstein have much more metrics because it runs Prusa link at Linux, and there's much more information that you can actually ingest. I will show you a demo, hopefully. Here? No? OK, this is running at Grafana code. Unfortunately, I forgot to start printing on the printer. But never mind, you will see how it looks if it's not printing. And by default, the exporter is multi-target. I have more than one printer, so I wanted multi-target exporter. Here you see information about the printer, and if you go here, then you will target temperature, success, and version of Prusa link. That's different for Prusa menu, of course. There is now it's the same version, but before it wasn't. Number of files, what you are printing, Z8 in time, a lot of good stuff. Actually, there are even syslog, but unfortunately, there are no data. But you can see there is information about 5 volt voltage, 24, and current, the adjustment, while it's not needed, of course, because it's next to it. But you can actually adjust at MK4 or XL. And there are nozzle current, nozzle voltage, a lot of interesting things you can use and experiment with. And this is the overview. As I show you, there was multiple printers. Right now there is one, and there's no mini. But I don't know why there is no mini. It should be there should be something. There should be just MK4. OK, and of course there's a live demo at the Grafana booth. You can watch how it works. It's in alpha stage, so I needed to start go run dot and started Prometheus Expert outside of Docker Compose up because it didn't work. Something with network, and thank you. That's it. Thank you for your everything and time for questions.
Thank you so much. Do we have questions? OK, Kemal, do you see? Yeah.
Thanks for the talk. So printing is sometimes a black box. Once I was printing something 5 times, worked flawlessly. Next day I printed the same thing, and it failed 10 times in a row. Can I use any of this to detect print failures or a reason about why something fails?
Well, of course you can, but it depends, as always. You can set, for example, alert that you have 68% of print done, but print speed is 0, for example, then you know if it failed, and you can, for example, there could be issue with a heater, and you can see that, for example, peak of temperature at nozzle, for example.
Okay, thanks.
Please, if you have a question, raise your hand so we can already come to you just in case.
I'm curious about how do you scale up when you add more printers? I mean, you have a Raspberry Pi there. Okay, it's not really Prometheus related question, but still, I'm curious how you scale up. For example, do you have some kind of distribution which automatically, when it's deployed, when it's installed in the SD card, it connects to the rest of the network? How this is done?
That's the issue that we occurring because we don't. Well, right in the company is used that syslog solution of metrics, and there was we were able to run only one instance of that Python regex script. So it was usable for like 30 printers, and you need to run another instance and send data to another distance. And you need to configure printer to send them. There was I know that internal IT made some kind of load balancing, but that's not something I know honestly. And of course, in our Kubernetes cluster, there is handled scaling automatically. And if I can answer to that, Golang exporter, that it was in alpha stage, so I don't need to answer this question yet about scaling.
Any other questions? I guess then that's it. Go and check out the live demo at the Grafana booth. Very cool stuff. Here's your speaker gift. Thank you again so much.